Supply chain planning relies on rigorous frameworks like those established by ASCM and APEX. At the core of these frameworks is a structural tension between two opposing forces. On one side, the market demands total flexibility to absorb shifting customer orders. On the other side, the factory floor requires absolute stability to execute production efficiently. When volatile demand signals continuously alter your production schedules, you get a chaotic phenomenon known as system nervousness. This constant schedule churn wastes capital. Materials arrive late, labor sits idle, and eventually the planning department loses all operational credibility. To prevent this, engineers implement rigid boundary controls. These controls shield the physical execution phase from market volatility. Unrestricted market flexibility eventually erodes the stability required for reliable execution. Planners manage demand over a specific duration, known as the planning horizon. The time fence is a policy-driven control boundary within that horizon, separate from the concept of physical duration. This diagram maps the planning horizon. As a plan approaches execution, represented here as today, the authority to alter orders, quantities, or schedules strictly decreases. The closer the schedule moves to the current day, the less authority planners have to intervene. This rule forces a structural separation between the theoretical act of planning and the physical, concrete act of execution. The time fence provides the architectural framework necessary to convert a theoretical forecast into an actionable production order. Most master production schedules and S&OP processes divide the planning horizon into 3 standard zones. The outermost zone is the liquid time fence. This long-range segment is driven by rough-cut capacity planning and assumptions without firm capital commitments. Here, changes are freely allowed. Plans in the liquid zone are merely forecasts. Next is the slushy, or firm, time fence. This is a mid-range zone where changes are permissible but heavily constrained. Altering a schedule in the slushy zone requires rigorous impact analysis. Management must evaluate specific operational trade-offs because adjustments here incur costs. Finally, the frozen time fence sits closest to execution. Here, materials, capacity, and labor are irreversibly committed. The operational mandate of the frozen zone is absolute. No changes are permitted without high-level executive override. What is scheduled is exactly what we will build. Together, these 3 zones function as a step-down transformer, gradually filtering out market volatility before it ever reaches the factory floor. Why do these administrative rules escalate sharply as production nears? This graph maps the cost of change against time to execution. In the liquid zone, the curve is flat. The cost of change is practically zero because orders exist only as digital data and theoretical forecasts. As we cross into the slushy zone, the curve rises. Costs accumulate from expediting fees, shifted priorities, and preliminary supplier commitments. Inside the frozen zone, the cost of change peaks. Altering the schedule here results in wasted physical materials, idle labor, and the loss of sequenced production runs. The strict administrative structure of time fences is a direct mathematical reflection of this exponentially increasing cost of change. Time fences are policy-driven. Management must customize their temporal duration to fit specific operational realities, as seen in this matrix comparing 3 distinct industries. Automotive manufacturing utilizes a highly compressed timeline, relying on a rigid 1 to 2 week frozen fence to maintain precise just-in-time sequencing. Retail fashion takes a different approach. It maintains an extremely long liquid fence to absorb intense seasonal demand shifts before committing to production. In pharmaceuticals, extended frozen fences are standard. They are driven not by manufacturing speed, but by strict regulatory validation and compliance protocols. A properly engineered time fence maps perfectly to the physical, temporal, and regulatory constraints of the product it governs. Supply chain professionals often confuse lead time with a time fence. Lead time measures the physical duration required for procurement or production. A time fence is a purely administrative control rule governing when you can intervene. Another common misconception surrounds enterprise software. An ERP system does not automatically optimize time fences. It merely enforces the boundary rules defined by human management. Management must avoid the optimization trap. Engineering a frozen fence that is too short creates operational instability, while one that is too long generates market inflexibility. Human policy design, not software automation, dictates the ultimate performance of the supply chain. These rules operate aggressively inside the master production schedule, material requirements planning, and order promising. Time fences act as the definitive boundary controls inside the planning horizon. The tripartite zones exist for one primary reason: to mitigate the exponentially increasing cost of change as a plan nears reality. Consider your own organization. Does it suffer more from rigid inflexibility or from chaotic overflexibility? Having time fences explicitly defined in an ERP system is useless if planners systematically bypass those rules to accommodate daily crises. True operational maturity lies in balancing system flexibility with execution reliability. That balance is secured entirely by the unwavering discipline of the time fence.